This WWDC, Apple introduced Swift charts, a convenient way to add charts to your app with SwiftUI. But can it handle data that's changed several times per second? Well, I ran a little experiment to test it, making an audio visualizer using the BarMark, and it actually runs a lot better than I would expect. On a real device, it's pretty much the same thing. Now, I'll show you how I made it. Let's get to Xcode. In our content view, let's start by creating a regular chart. To do that, we import charts and create a state variable to hold the data. For complex charts, you want to make an identifiable struct, but for our demo, an array of floats is enough. Let's populate it with some random values so we can see in the preview. At the body, we create the chart, and because we use the indexes, we enumerate the data. Now, for each element, we get the index, and we call the value magnitude. For the BarMark, we'll name the x-axis frequency and set it to the index. The y-axis is the magnitude, so let's label it that, but the names could be anything, as we won't show it on the chart. Cool, we have a working chart. It's time to add some music. Let's first create some constants, to keep the code clean and easier to tweak later. Bar amount and magnitude limit will replace the hard-coded numbers for our initial data. Instead of use combine to update the UI every time the audio data is processed, I'll create a timer for better control. Whenever the timer ticks, set it to run a function that we'll call update data. We need an audio to play, so I'll drag this MP3 file that I downloaded from museopen.org. I'll also add this class I've made beforehand. Showing it step by step will go beyond the scope for this demo, but here is a quick overview of what it does. We'll use two frameworks for this. AV Foundation to load and play the audio file, and Accelerate that give us many tools for high-performance computation, exactly what we need to process the audio. This will be a singleton, so I create the shared instance here. Two of the properties are exposed externally. Player will let us control the music. FFT magnitudes is the list of values that we'll show in the chart. After some setup, we load the MP3 file and send it to the player. Okay, here's where things get a little complicated. In order to analyze the frequencies, we need to process the file in small chunks. This install tab will accumulate the audio data in a buffer, and when this buffer gets to a set size, it will send it to this closure. We get this data and store it to the FFT magnitudes property after passing through the FFT method. FFT stands for Fast Fourier Transform. It decomposes the sound wave to the pure frequencies that make it. To learn more on Fourier Transform, I recommend this video by 3Blue1Brown. The code for this function was based on this article by Alex Barbilescu. It's very detailed and he explained much better than I would ever do. All the links are in the description, where you'll also find the source code for this project. Back to the content view, we'll get the shared instance, and at update data, we can now send the magnitudes array to our state variable. But it doesn't make sense to keep updating the data when the audio isn't playing. We can create a Boolean state to control that. Let's wrap the chart with a VStack, so we can add a button to control the player. We can play the music and see the chart updating. But it's quite weird right now. Swift charts will keep trying to resize the bars to fit the space. Let's make the scale fixed by setting the domain. With a map, the magnitude values can be trimmed to avoid exceeding the limit. The movement is quite choppy because our data is updating 20 times per second. We can wrap the data update with animation. Let's also get rid of the grid lines and make the chart smaller. That's it. We got an audio visualizer running smoothly with Swift charts. Let's now add more visual elements to make it look like an actual player and see if you affect the performance. But before that, consider giving a thumbs up. This is my first video on YouTube and it would help so much. Thank you. I'll begin by moving the play button to another view, so I can add extra elements to mock a player. The elements don't have a function for the demo, so I'm keeping everything as static images and texts. Now let's give a background to this block and move the elements to the bottom by wrapping everything with another VStack and adding a spacer. I'll set the color scheme to dark and create another view for the background. Let's grab an image from Wikipedia and fade it when it's loaded. A gradient will give more contrast between the background and the player. For the chart, we can make the bars change from green to orange as they get taller by using the HSP color space. A darker background will make the chart pop a little more. We're done! Even with more elements, the chart still runs smoothly. We can even reduce the update interval to make it more responsive to the music. Thank you for watching. This is the first of many videos on SwiftUI that I plan to make, so I hope to see you soon. Bye!